Have you ever paused to wonder why the entire cosmos is in constant motion, yet you feel perfectly, peacefully still? Right now, beneath you, Earth rotates at more than 1,000 miles each hour. At the same time, our planet sweeps around the Sun at 67,000 miles per hour, while the solar system itself glides through our galaxy at nearly 500,000 miles per hour. And yet, you feel nothing. Your pulse remains steady. Your breathing flows undisturbed. But perhaps this stillness is the universe's most beautiful illusion. Perhaps time itself is simply the whisper of an ancient rotation, one that began before atoms existed, before light, before anything could remember. Tonight, let yourself drift into this mystery, not merely to wonder why things move, but to understand why nothing in existence can ever stop moving. Before we float deeper, if it touches your heart, a gentle like or subscribe would warm mine. Each gesture of support breathes life into these stories and reminds me that these quiet explorations still reach kind souls like yours. Now, let your eyes close softly, allow the hum of the cosmos to settle beneath your awareness, and come with me into the spinning center of all things. Beneath your resting body, Earth turns at over 1,000 miles each hour. Simultaneously, it travels around our star at 67,000 miles per hour. And while you breathe in this moment, our entire solar system sails through the Milky Way at 490,000 miles per hour. Yet somehow, we sense none of it. The water in your glass sits perfectly still. The air around you doesn't pull or drag. The stars appear motionless in their ancient positions. This is one of existence's profound illusions, a beautiful paradox where motion and tranquility become one. From the tiniest electron to the most enormous cluster of galaxies, everything rotates. Atoms turn, planets circle their stars, galaxies spiral outward in magnificent patterns of light and cosmic dust. Even the universe itself may possess a subtle, vast rotation woven into its fundamental nature. But why, if all things move endlessly, do we experience such profound calm? The answer rests in inertia, one of the quietest yet most powerful forces in all of physics. Isaac Newton revealed this truth centuries ago. Objects in motion continue their motion unless something external acts upon them. We move with Earth, not against her. Your body, the atmosphere, the oceans, the mountains, everything turns together, bound in one silent, shared rhythm. To perceive motion, you need contrast, you need change. But no such change exists here. Earth's rotation is constant, smooth, and incredibly ancient. Astronauts floating in orbit at 17,500 miles per hour experience this same deep calm. Without friction from air, motion becomes indistinguishable from perfect stillness. This phenomenon carries a name: uniform motion. It explains why you can enjoy warm tea aboard an airplane traveling 500 miles per hour. And here's something that might surprise you. Neil deGrasse Tyson once observed that we inhabit a space rock orbiting a star that orbits a galaxy that moves through the universe, and somehow, we call this home. Our senses developed to help us walk and run, not to perceive the rotation of a planet thousands of miles across. They respond to acceleration, to sudden changes, not to steady velocity. That's why you feel a vehicle starting, but not its steady cruise along the highway. Yet scientists possess ways to measure this hidden motion. The Foucault pendulum, first revealed to the world in 1851, swings freely while the ground beneath it slowly rotates. Its gentle twist over many hours makes Earth's spin visible in the most peaceful way. This rotation creates day and night, stabilizes our protective magnetic field, and shields us from harsh solar radiation. NASA has observed that Earth's rotation gradually slows, mostly because of the Moon's tidal influence, adding roughly 1.7 milliseconds to each day's length every century. When we look beyond our planet, rotation reveals itself as a cosmic signature. Stars emerge from collapsing clouds, and as those clouds compress, they spin faster and faster. This is conservation of angular momentum, the same natural law that makes a figure skater spin more rapidly when drawing her arms inward. The Milky Way completes one full rotation every 230 million years, carrying hundreds of billions of stars in a spiral dance that began before our planet formed. The James Webb Space Telescope has captured images of galaxies more than 13 billion light-years distant, and even those ancient primordial galaxies show clear signs of rotation. The tendency to spin exists within the universe's very essence. According to Einstein's relativity, no absolute motion exists, only motion relative to something else. From our perspective here on Earth, we rest while the universe moves around us. This symmetry maintains physics, consistency, and transforms our stillness into an elegant illusion of perspective. The quiet you experience now isn't the absence of motion, it's the harmony of everything moving together in perfect unison. Take a slow, deep breath. You're spinning, you always have been, and the silence surrounding you is simply the sound of everything moving as one. But now, let me ask you something profound. If you could travel back to the very first second after the Big Bang, what would greet you? Would there be light, sound, or would there only be sudden motion, a swirl, a twist, the universe's very first rotation of everything that would ever come to exist? The question of what gave the universe its original spin lies buried within time's earliest moments. Astronomers call this the Planck arrow, the first 10 to the negative 43rd seconds after the Big Bang. What we can understand suggests something extraordinary. The universe may have been born already in motion. Scientists studying the cosmic microwave background, the faint afterglow of the Big Bang, detected by satellites like WMAP and Planck, have discovered tiny irregularities. These patterns reveal that the early universe wasn't perfectly uniform. Some researchers noticed something even stranger, a faint alignment they nicknamed the axis of evil, hinting that the universe might possess a preferred direction of rotation. How could such rotation begin at the very dawn of existence? The answer might rest in quantum fluctuations, tiny random energy variations when the universe existed smaller than an atom. When the Big Bang unfolded, those fluctuations were stretched by cosmic inflation, transforming subtle jitters into swirling motions, the cosmos's first spins. Alan Guth's inflation theory helps explain why the universe appears smooth, yet contains seeds of structure. Recent observations suggest that during inflation, subtle rotational patterns called B-modes may have existed in primordial gravitational waves, fossil records of the universe's first rotation. As the universe cooled, matter formed first quarks, then protons, then atoms. Each carried tiny amounts of angular momentum. When gravity gathered them into clouds and galaxies, that ancient momentum was preserved. In physics, nothing spins from nothing. Motion must arise from motion. Therefore, the first spin had to exist from the very beginning. In 2011, researchers analyzed over 15,000 spiral galaxies and found a subtle preference in rotation, Direxion imbalance that might trace directly back to the early universe's spin. Even dark matter halos twist and rotate, guiding visible galaxies like cosmic whirlpools, guiding floating leaves. The auric symmetry breaking. In the earliest fractions of a second, forces that were once united split apart. When that symmetry broke, tiny imperfections appeared, and those imperfections allowed motion to exist. In a perfectly balanced universe, nothing could move, but a slightly unbalanced one could dance. In 2020, astrophysicist Laia Shamir analyzed over 200,000 galaxies and discovered they tend to rotate more in one direction than the other, suggesting large-scale cosmic spin. Even at the quantum level, spin is fundamental. Every particle carries intrinsic spin, not physical spinning exactly, but a deeper mathematical rotation encoded in nature's laws. As Feynman expressed, particles simply have spin as they have mass. And this leads us to a beautiful realization. When we ask who set the universe spinning, the most honest answer may be, the universe was born already in motion. The spin wasn't created, it was inherited from existence itself. Take another gentle breath. The atoms forming your body are still turning with that first impulse from nearly 14 billion years ago. From the tiniest electron to the swirl of the Milky Way, the same rotation continues, unbroken across all of time. Without rotation, Earth would fall silent. No day, no night, no weather patterns. Only one frozen side and one scorched cedar, lifeless world adrift in harsh light. But because Earth spins, this planet breathes with life. Earth's rotation near the equator reaches about 1,037 miles per hour, completing one full turn every 23 hours, 56 minutes, and 4 seconds. This steady rhythm establishes the pace for all biological and environmental cycles. The first consequence is day and night alternation, distributing sunlight and creating temperature differences that drive wind, ocean currents, and weather systems. Without rotation, one hemisphere would roast under eternal daylight, while the other froze in endless darkness. Rotation also generates Earth's magnetic field. Deep beneath our feet, the liquid iron core churns continuously, generating a magnetic dynamo. This field deflects the solar wind-charged particles that would otherwise strip away our atmosphere. As happened long ago on Mars. Mars rotates once every 24.6 hours, almost like Earth, but it's smaller. Cooled core lost its magnetic field ages ago, allowing radiation to gradually erode its air and water away. Earth's spin also governs weather through something called the Coriolis effect. Because Earth turns air, moving from equator to poles curves, creating the spiraling systems that define our weather: hurricanes, jet streams, ocean currents. NASA simulations demonstrate that slower rotation causes one side to overheat while the other freezes. Faster rotation generates extreme winds. Earth's 24-hour rhythm is nearly perfect for life. But there's something even more remarkable about this rhythm. Living organisms evolve circadian rhythms, internal biological clocks that synchronize to this cycle. Every cell carries a molecular timekeeper. If Earth stopped rotating, this biological harmony would shatter completely. The Moon, formed from a massive collision billions of years ago, has been gradually slowing Earth's spin through tidal forces. This slowing lengthens our days and keeps our axial tilts stable, preventing extreme climate swings that would make life impossible. Jupiter spins every 9 hours 56 minutes, the fastest rotation in our solar system, driving ferocious storms, including the Great Red Spot. Venus rotates backward, extremely slowly, with almost no magnetic field, trapped in a runaway greenhouse effect that makes its surface hot enough to melt lead. Rotation isn't optional for habitability, it's fundamental to life's existence. Scientists using the James Webb Space Telescope observe distant exoplanets, discovering that those with measurable spins show clearer signs of chemical balance and stable temperatures. A study from 2021 noted that rapidly spinning exoplanets maintain magnetic fields longer, extending the possibility of liquid water. So yes, spinning made life possible. Rotation shapes day length, temperature regulation, atmospheric retention, weather patterns, and magnetic protection. Life thrives, not despite motion, but because of it. As Neil deGrasse Tyson said, "We are not just in the universe, we are of the universe." Take a peaceful moment. Every rotation carries the whisper of 4.5 billion years of delicate balance. If Earth stopped spinning, the oceans would surge toward the poles and the atmosphere would collapse. But tonight, as it spins gently beneath you, everything functions perfectly. At extreme velocities, rotation transcends simple motion and becomes distortion itself. Spinning objects no longer just move through space, they begin to pull at time itself. Einstein's general relativity predicted that gravity and motion are inseparable. The greater the spin, the more it twists space-time around it. This twisting is called frame dragging. NASA's Gravity Probe B experiment confirmed that Earth's rotation drags space-time by about 0.000011 degrees per year. Even our gentle planet bends the flow of time itself. Now imagine a rotation billions of times faster, a neutron star. When a massive star collapses, it compresses matter so intensely that protons and electrons merge together. The result? An object 12 miles wide containing more mass than our Sun, spinning up to 700 times every single second. These pulsars create the strongest known magnetic fields in existence and twist space-time so violently that time ticks more slowly nearby. This is gravitational time dilation. Time runs slower in regions of stronger gravity or faster motion. And here's where reality becomes truly dreamlike. Near a black hole, spinning black hole, space-time itself is pulled into rotation. Close to the event horizon, that rotation approaches the speed of light. Nothing can resist being dragged along with it. The region where this occurs is called the ergosphere. Within it, nothing can remain stationary. Every particle must rotate with the black hole. Your clock would tick slower than those on Earth minutes, for you could become ours for the universe. The Event Horizon Telescope captured images of black holes in M87 and Sagittarius A, showing luminous rings of matter spiraling around them, visual proof that rotation bends both light and time itself. Even GPS satellites must correct for time dilation. In orbit, where gravity is weaker, their clocks run 38 microseconds faster per day. Without these corrections, navigation errors would accumulate rapidly. From gentle planets to violent black holes, the universe uses spin to sculpt both motion and time. What we call now is different everywhere, depending on how fast spacetime is turning. As Kip Thorne explained, in warped spacetime near a spinning black hole, the future of one observer can become the past of another. Take a slow, peaceful breath. Right now, your sense of time is tied to Earth's gentle spin, the sun's gravitational pull, the galaxy's turn. You are surrounded by motion so precise, it writes the very seconds you live within. Galaxies spin at impossible speeds. Stars on their outer edges move so fast they should fly apart, scattered like sparks from a turning wheel. And yet they remain bound together. Something unseen is holding them in place. Astronomers call it dark matter. The mystery began in the 1930s when Fritz Zwicky studied the Coma cluster and found galaxies moving too fast for their visible mass to hold them together. He proposed dark matter, an unseen mass providing the missing gravity. In the 1970s, Vera Rubin measured rotation curves of spiral galaxies and discovered something unexpected. Stars far from galactic centers orbited just as fast as those near the core. According to gravity's rules, orbital speed should decrease outward, but Rubin's measurements were flat constant across the entire galaxy. Something unseen supplied extra gravity throughout the galaxy. What they discovered changed everything we thought we knew. Dark matter now appears to compose 85% of all matter, roughly 5 times more than all visible matter combined. Galaxies sit inside vast dark matter halos, invisible spheres extending far beyond their visible edges, acting as scaffolding that binds stars together. The European Space Agency observes this through gravitational lensing, the bending of light by massive objects. When light from distant galaxies passes near dark matter clusters, the unseen mass warps spacetime, creating graceful arcs in space. The Bullet Cluster collision provided unmistakable proof. X-rays showed hot gas lagging behind, but gravitational lensing revealed most mass lay ahead, separated from visible matter. The bulk was invisible to all telescopes. Dark matter doesn't interact with light or electromagnetic forces, only through gravity. Leading candidates include whimsically interacting massive particles and axions. Underground experiments continue searching for these elusive particles. The James Webb Space Telescope observes early galaxies less than 400 million years after the Big Bang, already showing stable rotation suggesting dark matter halos formed early, shaping the universe before the first stars ever ignited. Computer simulations demonstrate that without dark matter, galaxies would never form. Matter would remain evenly spread across space. Dark matter provided the invisible scaffolding upon which visible matter could condense and create structure. Our Milky Way orbits the galactic center at 514,000 miles per hour. At that tremendous speed, given visible mass alone, our galaxy should have torn itself apart long ago. But the dark matter halo extending perhaps 200,000 light-years beyond the visible disk adds necessary mass to keep everything bound together. The European Space Agency's Planck satellite estimates the universe as 68% dark energy, 27% dark matter, and only 5% ordinary matter. Everything we can see accounts for just 1/20th of what actually exists. It's remarkable to realize that what keeps galaxies whole is something we cannot see, touch, or directly detect. Yet its gravitational melody holds the cosmos in perfect tune. Take another gentle breath. Every star you've ever gazed upon is balanced upon something, invisible forces that act without being seen, guiding the motion of everything that spins through space. But the mystery of rotation goes even deeper, right into the heart of life itself. Every living thing on Earth is twisted in the same direction. Your DNA spirals to the right. The amino acids building every cell in your body bend to the left. This one-sidedness, called chirality, is one of biology's deepest mysteries. Life, down to its molecular shape, has a preferred direction, the spin. In chemistry, chirality means handedness. Certain molecules exist in two mirror forms, like left and right hands. In most chemical reactions, both forms create equally. But in living organisms, only one hand is ever chosen. DNA and RNA always twist right. Amino acids always twist left. If chemistry produces both directions equally, something outside biology must have nudged life toward one side before life even began. One clue arrives from ancient starlight. young massive stars emitted intense, ultraviolet radiation that became circularly polarized as it scattered through magnetic dust clouds. According to NASA's Astrobiology Institute, this polarized light could selectively destroy one type of amino acid over the other. The European Space Agency's Rosetta mission detected organic molecules on Comet 67P, showing signs of asymmetry hinting chiral bias existed before life began on Earth. The direction of life's molecules may have been inherited from interstellar chemistry shaped by cosmic light. The Murchison meteorite from 1969 contained over 70 amino acids with a slight excess of left-handed forms, preserving chemical fingerprints from before our solar system even formed. Y left for amino acids and right for DNA. They may complement each other perfectly, one determining structure, the other providing stability. Left-handed amino acids, fold proteins that bond seamlessly with right-handed nucleic acids. This asymmetry traces back to quantum imbalances. Experiments at CERN confirmed that neutrinos always spin left-handed. This universal handedness parity violation shows that fundamental physics isn't perfectly symmetrical. In 1956, physicists Chen-Shong Wu and Song-Dao Li proved that the weak nuclear force does UNT treat left and right equally. Nature is not as symmetrical as it appears. In 2011, astronomer Lia Shamir analyzed tens of thousands of galaxies and found a small imbalance in rotation, direction suggesting a large-scale directional pattern, perhaps a relic of the universe's early spin. The James Webb Space Telescope studies complex organics in star-forming regions, detecting prebiotic compounds forming under polarized starlight, suggesting chemical seeds of life naturally inherit directionality from their cosmic environment. And this brings us to a profound truth. The universe's spin decided the direction of life. From spinning galaxies to the handedness of neutrinos, from polarized light to chiral molecules, every scale prefers motion in one direction. Life is not random, it's a continuation of the universe's earliest rotation, written into every strand of DNA within you. As Carl Sagan reflected, we are made of star stuff. Perhaps we're also made of the spin of those stars. Every rotation gradually slows. Earth's days grow longer, galaxies drift apart. Even stars are burning down toward darkness. The universe that began with a great spin seems slowly to be unwinding, but can motion truly vanish? Or does it simply fade, spreading thinner across infinite space? Energy doesn't disappear, it disperses. So too with spin. It doesn't stop, it diffuses across time. Each century, the moon's gravity slows Earth's rotation by 1.7 milliseconds, transferring energy outward. The moon drifts away by 1.5 inches yearly. Apollo missions' laser reflectors confirm this drift with millimeter precision. If this continues indefinitely, Earth's rotation will one day lock with the moon's orbit, always showing the same face to the other. It will mark the end of tides, the end of our daily cycles. Mercury is trapped in 322 spin orbit, resonance with the Sun. Venus, with its dense atmosphere, crawls one rotation every 243 Earth days, backward. Mars gradually loses rotational speed. Over cosmic timescale, spin is not forever. It's a rhythm winding down towards silence. Astronomers using Hubble and the Very Large Telescope measured ancient galaxies billions of light years away. They spun faster, with tighter spiral arms and denser cores. As time passes, gravitational interactions and cosmic expansion gradually sap that motion away. When galaxies merge, their dark matter halos interact, redistributing angular momentum outward, leaving galaxies rounder, slower, more diffuse. The European Space Agency's Gaia mission maps 1.8 billion stars, revealing that even the Milky Way is evolving towards stillness. Eventually, it will collide with Andromeda in slow fusion, settling into a nearly motionless elliptical galaxy. But spin doesn't simply disappear, it transforms. When massive stars die, they collapse inward, conserving angular momentum and spinning faster, creating neutron stars rotating hundreds of times per second. NASA's NICERI observed pulsars spinning 716 times per second. Yet even these slow down over time, radiating energy as gravitational waves and magnetic fields. Stars fade. Black holes, the last great engines of spin, slowly evaporate through Hawking radiation. Even black holes aren't eternal. They leak energy over unimaginable timescales. The LISA mission planned for the 2030s will detect gravitational whispers waves from spinning black holes merging and fading. Each detection records rotation being released into space-time itself. Will the universe ever stop spinning completely? Not entirely. Angular momentum cannot be destroyed, only spread thinner and thinner. The universe never stops moving. It only redistributes motion across vast distances and timescales. In the far future, after the last stars die, the universe enters what physicists call heat death. Energy will be evenly distributed throughout space. No temperature gradients, no flow, no reason to move. Rotation persists mathematically, but without structure, it loses meaning. Some call this the cosmic silence, final calm after every vibration, every orbit, every spin fades away. Even so, spin leaves fingerprints that cannot be erased. From polarization patterns in the cosmic microwave background to space-time curvature around dying stars, the memory of motion remains encoded in reality itself. Take a long, peaceful breath. Right now, Earth's core still turns. Stars still orbit their galactic centers. The Milky Way still drifts through space. Every motion is a flicker of ancient rotation that will outlast you and me, but not eternity itself. When that eternity finally arrives, when the last spin stretches into silence, something remains, not movement itself, but the memory of movement, written into the fabric of existence. And now, let me share with you the most beautiful truth of all. Every atom inside you is spinning at this very moment. The electrons, protons, neutrons, quarks all caught in ceaseless motion. That motion isn't random or meaningless. It's a continuation, the faint echo of the universe's first rotation, still resonating after nearly 14 billion years. When you move, when you breathe, when your heart beats quietly in your chest, you're not separate from the cosmos. You're part of its oldest memory, motion itself. In physics, angular momentum represents the persistence of spin, the rule that keeps motion alive across time. According to NASA, angular momentum cannot be destroyed, only transferred from one form to another. Every spin in the universe is a continuation of the same original rotation that began at the Big Bang. The European Space Agency's Planck satellite shows the cosmic microwave background carries subtle directional differences some interpret these as traces of the universe's first angular momentum preserved across time. That primordial spin never vanished. It fragmented, spreading from galaxies down to atoms. When stars form, collapsing clouds rotate faster, conserving angular momentum. This gives rise to accretion disks, planetary systems, and black holes. Each planet carries a fragment of that original spin. Our atoms hold rotational memory within them. Electrons obey the quantum property of spin, fundamental angular momentum, intrinsic to all particles. Without it, chemistry wouldn't exist. NASA describes spin as the engine of atomic structure. Every thought crossing your mind represents an alignment of charged particles, a kind of ordered motion. Each brainwave, each neural signal is built upon rotations that have existed since the dawn of time. The magnetic fields generated by your neurons are faint echoes of the same principles that guide pulsars and magnetars across the universe. As Neil deGrasse Tyson beautifully expressed, we are not in the universe, we are part of the universe, and the universe is in us. Memory is pattern, preservation information, encoded in physical states. Atoms remember through spin orientation, cells through molecular structure, stars through rotation curves, the universe through space-time geometry itself. Einstein's relativity teaches that energy and momentum shape space-time's curvature. Every rotation leaves a small indentation, a swirl in reality. This is frame dragging, confirmed by gravity probe. Even your movements disturb space-time. The difference is just scale. Yorick atoms spin billions of times per second, generating magnetic interactions. Each micro-rotation contributes to the ongoing record of motion that began before humanity existed. And here's something profound to contemplate as you drift. If all motion leaves traces in space, then perhaps awareness is the way the universe perceives those traces through us. Not as emotion or consciousness in the human sense, but as physical continuity. Matter recognizing its own persistence across time. Even light carries angular momentum. Photons possess spin, determining how they polarize. Polarization patterns across the cosmic microwave background act as the oldest record of rotational memory in existence. When you gaze at starlight, you're literally seeing the memory of spin light twisted by billions of years of motion across space. That light enters your eyes, triggers chemical reactions, and becomes part of your neural motion. The universe doesn't just remember its spin, continues to experience it through every observer it creates. As Carl Sagan reflected, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. In physics, that knowing happens through motion, energy, and spin. The universe continuously encodes and retrieves its own history through physical processes. Take a breath slowly and gently. Every atom inside you continues to turn the same spin that once ignited the first stars in the ancient darkness. You are a moving archive, a living part of the universe's ongoing memory, carrying forward the motion that began at the dawn of time. So we've drifted together through the spinning heart of everything, from the stillness we feel on a turning Earth, to the universe's first rotation written into the fabric of space-time itself. We've seen how spin made life possible on this beautiful planet, how it bends time near black holes, how dark matter holds galaxies together when they spin too fast to exist by visible matter alone. We've discovered that life chose a direction left for amino acid, right for DNA, echoing the cosmic asymmetry that began at the Big Bang. We've watched as everything slowly unwinds over cosmic time, stars fading, galaxies drifting. Yet knowing that angular momentum can never truly disappear, only transform. Dispars become memory written into geometry itself. And we've realized something beautiful. We, every atom, every thought, every heartbeat are the universe remembering its own motion. Not separate observers watching from outside, but continuations of that first cosmic turn that set everything in motion. The stillness you feel right now is not absence, it's harmony. Everything moves together so smoothly you forget you're part of the eternal dance. Take one final, peaceful breath. Feel it gently. The gentle spin of Earth beneath your resting body, the orbit around the sun, the drift through the galaxy, the atoms within you, still turning with a rhythm established nearly 14 billion years ago. You are not standing still. You never were. You are gliding through a cosmic river, constantly, endlessly. And in that perfect balance of motion and calm, life finds its quiet rhythm. Let yourself float now. Let the spinning universe carry you into peaceful rest. You are safe. You are held. You are part of the eternal dance. And as you drift into sleep, you know that you are traveling, spinning softly through space and time exactly as you were always meant to.